Okay, let me explain how to do these quadratic word problems. I'm really not teaching you anything new. All I'm doing is just one of the examples and just giving you some hints, tips along the way. So we've got Jason. He's jumping off a cliff into the ocean. There's an equation that gives us the function that I'm going to be graphing, but I'm not going to do it very accurately. I'm just going to kind of sketch a graph so I just have an idea of what I'm supposed to find. So this says T is the time in seconds and H is the height in feet. So go draw, let's see, we'll draw a cliff. There's the cliff. We've got some water. He's jumping into the water. Here he's jumping off the edge of this cliff. He'll jump out and up a little bit and then land splash in the water. So that's his path. I'll just make my x-axis the water. So if it helps, we'll just like make it a little thicker. There's my x-axis. My y-axis is just this cliff here. All right. And the equation is given. Now, what I highly recommend is you go through and you read. Oh, whoop. Actually, before I read, I want to label my x and y axis. So it's not really the x-axis. This one is t and then h of t. But it still is the same way we would look at x and y. The x-axis or the t-axis is going to represent time in seconds. And then the h of t, that's the height in feet. So the first question, how long did it take for Jason to reach his maximum height? As soon as I see that word max, as soon as I see, I'm thinking the very top of my graph. And the very top of this graph, the max, that's our vertex. So I know I'm going to be finding the vertex. However, how long did it take is not the entire vertex. How long? That's the time. So when I do find this vertex here, we we only need to talk about the t-value of the vertex. We are only talking about the time. And another way that I could look at that is just that's going to be our axis of symmetry. The x value or the t-value, that'll be our axis of symmetry. So I'm just going to write myself a note, find the axis of symmetry. Then the second question, part B, says, what was the highest point that Jason reached? We talk about highest point. We're still talking about the max. But this time, I believe they want the number in feet. So that's going to be our h of t, the height. So we're going to be finding the y value of the vertex. Oops. And by the way, the y value of the vertex is also known as the max value. They are the same thing. And then Jason hit the water after how many seconds? So let me go find where he hit the water. So right here, that's going to be one of our x-intercepts. And it's actually the second x-intercept. Now, you might not see the first x-intercept because that is happening where time can't happen. So here's where time is 0, right at the origin. That's where time is 0. So to go negative, we can't have negative time. So that's why I didn't draw that part of the parabola because it's not useful in this situation. So when we find our x-intercepts, we're only going to use the second one. So Jason hit the water after how many seconds? That's going to be the bigger of the two x-intercepts. All right, so now I'm going to use my equation. My equation is in standard form. So recopy it right here. Now, if you don't know how to find the axis of symmetry in standard form, First of all, I highly recommend that you know it. We've been that's the way we started graphing when they were in standard form. And then from there, I taught you how to switch between the forms. So if you wanted to use complete the square to make it into vertex form, or if you wanted to try to factor and put it into factored form, those are other ways that you could do it. I'm just going to go way back to the original way that I taught you. And to find the axis of symmetry when it's in standard form, our formula is x equals negative b over 2a. So I'm going to plug in x equals negative 16 over 2 times negative 16. So a is negative 16, b is positive 16. From here, I'm going to simplify this. So if I am dividing a negative by negative, I get a positive, and I get 16 over 32. If you need to use your calculator to simplify this, I'm okay with that, but that reduces down to 1/2. So my axis of symmetry is 1/2, x equals 1/2. Now, that's not answering the question. The question is, how long did it take for Jason to reach his maximum height? The answer should be 1/2 of a second. So our answer is a answer with units, so it makes sense for the question that's asked. So looking at my graph, my vertex starts with 1/2. Now we need to find the y value because that's what the second part is. So going back, when I find my axis of symmetry to find the y value of the vertex, we are going to plug in the x equal to, and I'm saying x and I'm writing x, and oh my gosh, it's t. So sorry. I'm just going to keep saying x. Please forgive me. It's a habit. So we're going to plug in our t value that we got 1/2. We're going to plug in that value. So I'm going to do h of t. I'm going to do h of 1/2 equals negative 16 1/2 squared plus 16 times 1/2 plus 480. Again, you can use your calculator to find this. I'm going to do it by hand. Negative 16. To do 1/2 squared, I'll work over here. 1/2 times 1/2. We just multiply fractions straight across. We get 1 over 4. Okay, from here, multiplication. So I'm going to get negative times positive. I get negative 4. 16 times 1/4 is 4. 16 times 1/2 is 8. And so adding all that up, we get 484. So the highest point that Jason reached is 484 feet. So our vertex is 1/2 484. By the way, not to that we don't have to answer this question, but just looking at the original question, if I found the y-intercept, that would be at 480. And so 484 after a half a second, that seems reasonable. Just making sure that my answers make sense. All right, last thing we have to do is find the x-intercept, the second one, but I can't necessarily just find one. I'm going to find both and then just pick the right one. This finding the x-intercept, that is the exact same thing as solving the equation, and we went over the best method for solving each equation depending on what form it's in, what information you have. So I'm just going to look at this equation right here, and I'm not going to use square roots or undoing PEMDAS because I have that middle BX term. What I could do is I could take this and I could complete the square, put it into vertex form, and solve it that way. But I'm not going to. I'm going to go instead to where it says, do we have standard form with the BX term? And my choices are try factoring, or maybe quadratic formula. And this is totally up to you. because I'm making the video, I'm going to do it by factoring. So I'm going to go over factoring. First of all, we have to set it equal to 0. So I'm going to do it by factoring. This is not the only way that you have to do it. So before we even start factoring, it has to equal 0. So I'm going to plug in y equals 0, and I'm going to have leftover I'm not leftover on the other side, negative 16t squared plus 16t plus 480. Now, your first step of factoring, every single time ever that you ever factor, you always want to look to see if there's a GCF. And in this case, there is a GCF. It is negative 16. So I'm going to take out the GCF. When I take that out, it's in front, and I have left over t squared minus t minus 30. Now from here, if it factors easily, then I'm almost done. So I'm going to make two parentheses. Both of them are going to start with a t because this starts with just t squared. I'm looking at the negative 30, which tells me I need to have a plus and a minus. And then I'm going to think about factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Ooh, 5 and 6 sounds good. So I'm going to go and put 5 and 6 here. Then I'm going to check my answer. Now, you might be factoring using a grid, and that's totally fine. Either way, you should be checking your answer. I add up 5t and negative 6t, and that does work. It does equal negative t. So once I have it factored, now what I'm going to do is set each factor equal to 0. So I'm going to have, I don't set negative 16 equal to 0 because there's no variable in that. If I do set it equal to 0, that doesn't even make sense. So I'm just going to start with t plus 5 equals 0 and t minus 6 equals 0. I'm going to subtract 5 from both sides, or I will add 6 to both sides. We'll get t equals negative 5 and t equals 6. Now let's go right back up to our original picture. So we have a negative x-intercept at negative 5, and we have a positive one at 6. And we're only using the positive one because that's the only one that makes sense. So how many seconds before he hit the water? It took him 6 seconds. So what you need to do in this worksheet is you really need to take your time, draw a good picture, and then pay attention to those keywords like max or min. This one right here, I know some people struggle with after how many seconds will the rocket be 112 feet above the ground. So I can get you started on this one. It's h of t equals negative 16 t squared plus 128 t. By the way, the reason why I curve my t's is so that they don't look like plus signs. But for this, it says 112 feet above the ground. That means our height is 112. And then what we're asked to do is after how many seconds? So we're going to solve for t. All right, so then that's where you're going to decide which method. Before I even decide which method, I'm going to subtract 112 from both sides because I need to have this in standard form where it equals 0. So from there, I can try complete the square, I can try quadratic formula, or I can try factoring to solve to find t. Then the last thing that I want to give you a little heads up about, actually, there's a couple on this page, but this one right here where it says round to the nearest tenth of a second. So if it does not say round, you should be getting exact answers. If it says round, you should be getting a decimal, and that means you have to use your calculator. All right. It's number 4. I put a question that has grappling hook in it. So this one, you and your friend are hiking. You want to climb a ledge that's 20 feet above you. So we've got a ledge. It's 20 feet up there. So if you don't know what a grappling hook is, that might confuse you to exactly what's happening. So I Googled grappling hooks. You can see what I'm talking about. And it looks like this, and you can see it's used for hiking. It's something that people will attach to a rope and then throw up like a cliff. And then from there, they'll just climb up the rope. So that's what's going on here. So you just imagine that you're, standing down here, and then you're going to throw that grappling hook up, and it's going to attach. And then from there, you're going to see if you can uh, climb. But this says, can you throw it high enough to reach the ledge? So basically, you're seeing if you can throw it above 20 feet. You're trying to find out if the height can go above 20 feet. And when I mean the height, that's going to be the max height. We need that max height to be higher than 20 feet to be able to do this. Remember, if I said max, talking about the vertex. Okay, I think that's pretty much it for questions that people normally have. And if you do have some questions on this, write them down, circle of them. You can reach out to me at any point, send me an email, or make time to come see me. All right, have a great day. Bye.